Hello, everyone. Thank you for coming to my talk. It's an honor to present for you. And I'll be talking about smart contract design pattern, which is called Type-Driven Development. It's applicable elsewhere, but I think it's very useful for smart contracts, and I'm going to talk about it. First, the classic, a little about myself, just to give you some context about how and why I think about things the way I do. My name is Philip. I'm also known as Philogy online. I have almost 5 years experience working with smart contracts in various ways. I've done smart contract development for various DeFi protocols as a freelancer and for Sorella Labs. For the past 2 years, I've been an auditor, both for QuantStamp and now Spearbit as a lead security researcher, and I'm working on my own EVM compiler full-time. When we write contracts, the bar is very high, right? We need to write bug-free code or die. It's a bit exaggerated, but the list of teams who have successfully survived a critical bug on-chain is very small. And there's very great teams with good funding that basically have to shut down because they made a mistake in their contract. So when we write contracts, we really have a high bar to clear. You know, anybody who writes any other kind of software knows that, you know, if you're talking about bug-free software, that's like, you know, it's a unicorn. That doesn't exist. That's fantasy. But in DeFi, that's like what we have to do like every single day. We have to pull that off. Right? So, but in the real world, we have constraints, right? We don't have infinite time to make our contracts perfect. We have deadlines, we have schedules, we have projects, we have kind of partnership announcements. We only have so much budget allocated to audits. So the reality is that our final contract quality or security depends on the resources we have, but also how efficiently we use those resources. So we can either scale the resources or we can scale the productivity. And under this simple model, things that you might not intuitively expect to have an impact on security are actually quite important. Like, for example, developer productivity. If you can improve just smart contract developer productivity by 30%, then that's 30% that they can invest into testing. That's 30% they can invest into better designs or formal verification. Similarly, if you can make auditors more productive, that's more value you get out of your audits, etc. For another thing you might not immediately expect is, like, let's say you have like simple bugs that you usually catch anyway, like later in testing or maybe even audits, you know, like the low-hanging fruit that always gets found. If you can find that stuff earlier and more easily, that's also valuable. Like, even though you would have found it later anyway, the lower the cost to finding that and the sooner you find it, the better for the final result. And then counterintuitively, some things like, for example, a static analysis tool that has a very high false positive rate can actually be bad for security. Right? Even if it has a few good results, like some of the new AI tools, if it's like 90% garbage, the time you waste filtering that garbage is actually going to lead to you having a net worse contract. Right? So this is kind of where type-driven development comes in. It's a simple way how you can code and design your contracts that gives you productivity, efficiency, and like safety gains early on that can kind of compound into making your contract much better or more easily. So the high-level concepts of type-driven development are the following. It's, you want to leverage types as documentation, you want to leverage types as cheap static analysis, and you want to design your contract through types. And don't worry, I'm going to explain and elaborate on these concepts. But the high-level concept is really the compiler is your friend, and compiler error is much better than an error at runtime while testing, which is much better than an error at runtime in production. Right? So types are basically a thing that you can leverage that the compiler already gives you, a thing that you already deal with every day, but you can leverage it more to find out more about your contracts earlier. So let's dive into a case study. Easy Recover. It's the precompile that you use to recover a signer from a signature. Signer from a signature. And it's built into Solidity. And it's built into the compiler, but if you think about the signature, this is roughly it. I hope you can see it. It's large enough. So it accepts some parameters, and then it returns an address for the recovered signer. But for anyone here who codes contracts or audits, you know that there's a major footgun that you always have to like think about and double check when you use this function, which is you have to remember to check that the recovered address is not address 0. Because Solidity, the way to inform you about an error in the signature recovery is by returning like the sentinel value address 0. And this is kind of footgun prone, because if you don't check this, then your code will basically assume it has a valid signature for address 0, which can have all kind of weird consequences. And kind of the solution or the type-driven approach to making this better is you can very simply, you can just swap out the return type. Right? If you imagine this is like actual code that's defined, you can just define a custom type and have that be returned instead. And the great thing about this is that it's a very small change, right? It's like not even one line, and then maybe another line to actually define the type. And all of a sudden now, the compiler at compile time for free is telling you about this foot gun, right? And you made a simple change. And now this is a thing that as a developer, as an auditor, you never have to think about again. You can actually forget it. It no longer has to be in tutorials or whatever. The API informs you about it. And if you extend the type, you can now make it very easy to use, right? You can unwrap it to say you want to revert if there's an error, or you can check if it has an error and then handle it. And this is great because it also serves as documentation, right? One of the principles before is like if you read the function, if you read its definition, you now very clearly see what happens, what it can do. Now the compiler will also statically check this for you, and yeah, you don't have to think about it anymore. Next case study, yeah, this is, so if you can imagine this custom type kind of encapsulates both the address value and like the error state. The next case study is doing math with units. So often in DeFi or finance, you'll have to deal with different currencies and converting between them. And they're technically all numbers, but the numbers mean different things. And if you have like code like this, where you, for example, want to convert the value of one token in another using some price, and you have two functions to do it based on the direction, you want to make sure that you don't mix those up. But the function definition and the types, they don't tell you directly what goes with what. Like if your naming is good and maybe documentation, you can find it out, but it's still very footgun prone. Like when I use the function down there in the function do stuff, you'll see that it's actually very easy to mix these two up, right? I have amount in A, and it's used here and here. And actually, I'm not meant to use amount in A as the input to convert B to A, right? It's expecting B. But there's nothing that tells me that this can happen. So now, as a developer and auditor, at both stages, you have to track and think about this and like, OK, I have to remember this is amount in A, anywhere it's used, is it used correctly, etc. Even with the price, it's also just a uint. And it's also kind of poorly documented just with the parameter names. So again, solution is just implement a custom type. Very simple. You just define a type, and now they're incompatible. If you try to use it incorrectly, like down here, it'll give you a type error. And at compile time, which is the earliest possible place where you can get an error. In fact, depending on how well it works, you will even get the error in your editor before you even run Forge build, which is extremely nice because, again, it's a simple thing that arguably you would eventually discover down the line anyway, but it's a thing you never have to think about again. And it frees you up to think about the important things in your contract. And there's some boilerplate here related to the custom types, but it's a small price to pay, I think, for having just not having to worry about this issue anymore. Another nice advantage of this is we can leverage Solidity's function overloading to have it automatically choose the right function and simplify the naming. So instead of convert B to A and convert A to B, we just have convert, and the right method will be chosen automatically. The final case study I want to share with you is transfer ownership. So super typical. You have a public function. It accepts addresses. And again, you have this problem of address 0. Right? You might get address 0, and because of maybe like optimization, you're using address 0 to represent, OK, there is no owner actually more. It was renounced. So for that reason, you don't want to accept address 0. It's not a valid input. So you want to check against it. But if this is a library and you're implementing set owner, you don't actually know exactly whether people will check before they call set owner, or should set owner check it. So if you really want to be safe, if you really want to be safe, you're gonna be basically duplicating the verification logic, or you're going to be kind of optimizing and writing like a comment like, please check before you call this. And it's just not very robust. And again, it's a small detail, but it's a small detail you have to think about that uses up cognitive space and will make you slower development. So again, very simply, same solution. It's the hammer for all the nails. Make a custom type. Very simple. You just define a custom type, and now it's very clear. If I read the function signature and I want to use this function in a library, I know exactly what the requirements are. It's documented there. And if I just try to pass in a normal address, the compiler will tell me, hey, an address is not a non-zero address. It's not the same thing. Please convert them first. And again, same issues as like the inputs are not clear. And again, the solution is types. So as like a summary for when you will want to apply type-driven development is if you notice yourself documenting subtle requirements of your code in comments. then you can use types instead. And there'll be better documentation because you can think about documentation actually as code that's never run. Right? It's never run, it's never tested, it's just text. And as you change your code, as you change your logic, it's very easy for documentation to be outdated. And in fact, even as an auditor, I often skip reading the documentation of the project because one, it's often just bad. Two, often it's just out of date. And three, sometimes it'll hide like implicit ideas from the developer that are actually wrong and will kind of trick me or trick my mind into thinking that these things are true about the code when they're maybe not. So most of the time, I actually ignore documentation. Like sometimes for complex assembly code, it's nice to have documentation. But yeah, so types are nice because they actually test it. They're actually part of the interface. And as an auditor, they also help me. They also help me know that, OK, I don't have to worry about a certain thing anymore. Another tip for when to use type-driven development is when you want the caller of your function of your library, even if it's just yourself, to check or handle certain states, right? So errors is the primary example. Errors as values is, I think, a great pattern that you can leverage in your code. And then the next thing is if you're using the base types of Solidity for similar but distinct concepts. So units is one example if you're dealing with different currencies. A very simple, stupid one is also like ranges. Like instead of UN256, if your function is only meant to work with like values in the 32-bit range, well, then use a UN32. That's like also a very simple example of type-driven development. So wait a minute. Did you spot the problem in one of the previous examples? There was a small issue hidden in there. Raise your hand if you spotted it, if you think you spotted it. Just to make a survey of the crowd. OK, if I pull up this specific example, do you see it now maybe? Raise your hand if you did. OK, more people, good. Well, the issue is here exactly. The custom type you define is address. And you put it in a public interface. But Solidity doesn't really understand that it's a custom type that has special properties. It just sees it as an alias for address. So when your ABI encoding, decoding at the top level, even if somebody calls it with address 0, Solidity will say, hey, it's an address. That's fine, that's what I expect. And it'll create an instance of the non-zero address type with the value address 0, kind of breaking the thing that you wanted to achieve in the first place, right? So Solidity has no way to magically infer that that it was meant to check against 0, right? And this ends up creating like a hole in like your nice, safe type environment. And in general, when you're using type-driven development with Solidity, there's a few pitfalls you have to watch out for. I think it's a great pattern, and if you're programming outside of Solidity, it's really nice to apply. But just watch out for a few things. First, users and the compiler can manually create your custom types and completely ignore any assumptions you make about them, like the non-zero address situation. Then, if you're using structs, which are a different kind of custom type, like a custom type that contain many fields, it's not zero cost. Like it actually has decent gas overhead in terms of always being allocated in memory. So that's something to watch out for. Also, there's a lot of repetitive boilerplate potentially. So that's also like a small pitfall. But I think it's usually worth it. But yeah, that's another thing to watch out for. And then another thing is there's no standard library. Like the EC Recover example, that's built into Solidity. And if you want to contribute to that as a developer or change it, you can't really do that. So you have to rely on third-party libraries to kind of implement these patterns for the really like core stuff. So if we want to improve this, what can we do? Because if we think about all these like pitfalls related to trying to do type-driven development, they're really like language-level issues, right? So we have like two options. We can change the language, or we can build our own. So today, I'd like to introduce or announce my new project called Sensei. And it's a new smart contract language for the EVM that I'm developing. And kind of the tagline or the goal is I want to help good devs write better EVM contracts, right? So if you're a noob that's going to get hacked anyway, then it might not be the language for you. But I really want to give like the 80 percentile of devs that are like actually doing this professionally, like better tools to write nice contracts. So for the language, day one goals is I want fast compile times. This is a thing that everybody complains about Solidity that I think is quite important, is just fast compile times. The goal, and this might seem a bit ambitious, and I can explain later if somebody's interested, like why I think this is very feasible, but the goal is worst case for the largest project at any time. I want the worst case compile time to be 500 milliseconds. And this is like a barrier that will increasingly grow, as the language gains adoption and the largest project becomes larger and larger as people build larger things. Like, this will be like a continuously moving target. But I think this is a good goal to strive for, and there's a lot of reasons to believe that this is extremely feasible and very achievable. The next thing is a standard library, very basic. Like, the language should just ship with all the basic things you need, like out of the box. And then the last thing that I think is also like kind of underrated is just editor support. Like, I want autocomplete to work. I want go to definition to work. I want to see errors in my editor, and I want it to always work. Then specifically related to type-driven development, I want encapsulations. I want some better way to tell the compiler, to tell users when I'm developing a library or writing my own code that, hey, you can't touch these fields or you can't touch these functions. These are only for me in the library, and when you're using my thing, you only get to touch certain things. Another thing is for reducing boilerplate, generics. And the last thing is I want the compiler to do better gas optimization, so you don't have to worry about inline assembly and gas golfing and all of that. So a lot of you, when you hear this idea for a new language, you'll ask the very valid question, why? Why do we need a new language? We have so many. So what's the problem? Why don't you like them? Or why can't you just contribute to them and make them better? So the first is Solidity. Very popular, great language. It like bears most of DeFi. But in terms of actually contributing to it to make it better, it has a very large backlog of existing issues. And I feel like it's a code base that's very hard to get into. Furthermore, the team is very conservative about changes, partially rightfully so, but I do believe there's space to move faster, and I think that's an advantage of a new language. Is because you have no users at the beginning, you can move extremely quickly. You can leverage all the hindsight from the past 11 years, and then once you get the first users and you solidify the version, like by that time, you would have already taken advantage of your faster velocity for a very long time to develop a lot of features. Then there's Viper. Viper, I think, is also a very great language, actually kind of underrated. But their philosophy is kind of simplicity maximalism. Like, in terms of features that they want for the language, they want to keep it super simple, super readable, which is nice. But as soon as you want to build something more sophisticated, I do feel like it's lacking a lot of features and components in the language to make it scalable to write larger contracts. Another thing is they're building their own IR, but alone. And they're building it in kind of the silo in a way that's not reusable by other compilers. And not only do I think this is sad because I can't use their IR, but also because it means that other people like me who are building compilers will not contribute. And they will basically miss out on making their IR better than it could be. And then, yeah, there's like basic features that I think are missing. And then finally, there's core Solidity. So I don't know what the logo was, so I just cooked something up here. But basically, I think core Solidity is great, but it's still a very early stage. Like, I was just talking to some of the developers, and it's still like they say a research level like prototype that they have, and they're soon going to start the production one. But yeah, it's unclear how to contribute there. And I am also wondering, like, how long will it take to ship it? Because they have a very ambitious set of features. They're also still maintaining Sol C. And also, in terms of personal philosophy, in terms of how to design a language, I think it's interesting to explore another part of the design space where you have a less complex type system, but you make other features like compile time execution more powerful, and then you kind of get the same capabilities, but the actual implementation of the compiler and the theory becomes so much simpler. And then finally, beyond just languages, I think it'd be good in the space to have more competition. And personally, I'm finding it really fun to develop compilers. So I think, honestly, just having fun doing what you do, I think is also a very good reason to do things. So how do you get your hands on this? It's not a real language yet, Sensei. It's something that I'm actively developing. But I want to get something into the hands of people very soon. So if you're interested, I'm going to open a closed beta just to like curate the feedback and to make sure that I can do breaking changes very quickly without upsetting too many people. So if you want to stay up to date with announcements or how the progress is going, you can scan this QR code and join the Telegram channel. And then I'll inform you of like whatever developments I'm doing, and then eventually like send out an invite for people to join the closed beta. All right. And yeah, thanks for listening. I hope it wasn't too much. And yeah, please ask questions. Thank you for giving me your attention. And yeah, if you have more like direct questions, you can also DM me on any of these platforms. Thank you so much.
Thank you so much, Philogy. Great talk. It definitely puts a lot of things into perspective for ecosystem stakeholders and pushes everyone to refocus on improving the ecosystem in general and moving the language forward. Questions for you. At what point does TDD become too much to do beforehand?
Yeah, I mean, you can definitely get very nerd time, go very deep. I think that's why the language itself being a bit simpler is nice. Like there's some languages like theorem provers that give you extremely advanced type systems where you can basically take TDD to its logical conclusion and formally verify everything using types. So in a way, like the examples I showed, I think are very important. Like when you apply TDD, it should kind of look like that. Like it should be small changes where you very cleanly communicate requirements of your API. And also in terms of modeling state, it shouldn't add overhead. It should actually make things simpler. And there's some stuff in Solidity that's missing, like some types that make it very nice to like model your state of the contract, where TDD actually makes things simpler, where the sooner you do TDD, the simpler it is. But there's definitely cases where you can overdo it. Like for example, this often happens in Rust code bases where you have like generics on generics and interfaces, so it can be done too much. But that's the nice thing about Solidity and hopefully Sensei is that the type system is a bit simpler, so there's only so much you can actually do.
Thank you. These best practices are nice and can be implemented as a library framework for general use. Any intention to make one?
Yeah, definitely. I mean, as I mentioned, Sensei will ship with a standard library, and when I write the standard library, and when I accept contributions for the standard library, it'll focus on using TDD where appropriate to make sure the APIs are nice. Like for example, EC recover out of the box in Sensei will ship with like the API of address or error, so you never have to worry about that footgun.
And what are your thoughts on languages like Solidity or Sensei being formally verifiable by default?
Yeah, I think that's extremely important. That's also why I'm interested in building Sensei and having a simple type system. It's because the theory becomes much simpler. So if you want to formally verify it, the mechanisms and theory of your language is simpler. So yeah, I'm definitely in favor of that.
And not really a question, but someone said they're curious whether you're open to collaboration because they're building a new compiler.
Yes. So there's a few people building compilers. We actually have a group for this. So if you're developing a compiler as well and want to collaborate on IR, on the actual language design, syntax, anything, or just want to chat, just DM me. We have a group for compiler developers who are building like new EVM languages where we just chat and exchange ideas. So if you want to join that, just DM me and I'll invite you.
I guess the next DevConnect, we should have a compiler conf.
Yeah, absolutely. Yeah.
OK. Awesome. Thank you so much, Philogy, for your talk and answering all of the questions. That would be your time. Please give it up for Philogy. Amazing. Moving on to